Hi and welcome. I'm Eric from the .NET Amsterdam meetup. With me today is Jordi from Visual Studio, the Visual Studio user group, and George from the .NET Den Haag, the Hague user group. Fanny is not here at the moment. He is taking care of his kids which are ill. And we hope you all enjoy this session today. Do you want to introduce yourself, Jordi?
Sure. Hi, I'm Jordi from the Visual Studio user group from Belgium. We try to do a monthly user group session regarding everything .NET and Microsoft related. So yeah, we hope you can join us later this year and hope you have a good evening today.
Sorry, George, do you want to introduce yourself?
Yeah. Hi, I'm George. I'm from the Hague.NET Developers meetup group. We are a meetup group for .NET developers here in The Hague, in the Netherlands. And we don't have a real tight schedule. We don't have like a specific schedule, to be honest, but we try to have a meetup per month about .NET related technologies and everything that has to do with Microsoft .NET. That's it.
Awesome. So if you have any questions, ask them in the chat. On the YouTube chat, we will try to collect them and ask them either throughout the session or at the end at the question session. And let's get started. The floor is yours, Maarten.
All right, thank you. I'll remove some folks from the stream. There we go. And then switch the screen, and then we can actually see something. All right, here we go. Welcome from my side as well. It's kind of interesting that I'm talking at 3 user groups at the same time. You would not be able to do that in real life, but still, it's. I also miss hanging out and having a beer and some nice dinner, even if it's sandwiches or something with the folks at the user group. But then again, it is what it is. So welcome from my side as well. The talk of today that I'll be delivering is Microservices for Building an IDE, the innards of JetBrains Rider. And the idea of this talk is to go through some of the design decisions that we made while building this IDE and see why we made those decisions and how they came about and how they actually benefit from being in the IDE. So before we start, I quickly want to show you JetBrains Rider so you have an idea of what it is. So Rider is an IDE, which is the place where you do your typical coding. And what you'll see is that on the left-hand side, you have the typical Solution Explorer. I know in Visual Studio, for example, you'll see this on the right by default. In Rider, it's on the left. You can open up folders in there. You can open up code files in there. You can start coding. In code, you can start writing. If you mistype something, you will see that it will highlight that there's an error. If you forget something, it will also highlight that. And things will start happening once you type. So you'll see that this thing is missing. There's things like a NUKE package explorer where you can basically search on NUKE, install packages into your project and so on. On the right-hand side, there's database tools. All of that stuff is in the IDE, and it's really an IDE for .NET developments that you can use in your day-to-day work. So the focus of this talk is not really to dive into what Rider is as a product that you can use. The idea is really to go into why we made certain decisions and how it came about and is what the IDE looks like today. Just so you know, Rider is cross-platform. It's a full-stack .NET IDE, so it works with all languages in .NET world, whether that's VB.NET or C# or F#. It also works with all of the frameworks, which means classic .NET Framework, .NET Core, as well as Mono, if you're on Linux or on Mac. And if you want to do WinForms development on Windows, you can even do that with Rider as well. So that means that to make all of those things work, you will see later on during this talk that there's a couple of things that we had to do to make those actually work as well. It's fast, it's lightweight, and it's also a combination of 2 IDEs, namely IntelliJ IDEA, which is the JetBrains Java IDE. That's the front end that powers Rider. And ReSharper, which is the backend. So all of the C# and .NET code analysis that you will see is powered by ReSharper. And the idea of Rider is to be more productive as a developer and be able to do that cross-platform and have the same IDE on all of those platforms. Now, before we dive into some code and architecture and so on, I quickly want to give you some history of how ReSharper came about. So ReSharper and IntelliJ and so on are products of JetBrains, the company that I work for. And JetBrains was founded in the year 2000. And it actually started with a very, very simple tool called IntelliJ Renamer. And IntelliJ Renamer was a tool that would allow you to open up a Java class and rename that class, and it would rename all of the files and update all of the references and so on. So a refactoring as a tool, as it were. Now in 2001, we decided to make that IntelliJ an actual IDE. And in the year 2004, we also introduced a second product, namely ReSharper. Now the reason for that was that somewhere in 2002, 2003 timeframe, another IDE came to market in the Java space, which was Eclipse. And JetBrains decided, well, we can no longer do just this Java IDE, IntelliJ. We also have to come up with ReSharper and so on. Now, ReSharper was developed in C# and was developed on .NET and is a really separate product and from IntelliJ. And it still exists today. IntelliJ itself has evolved into over 20 IDEs today, all based on the same core. So IntelliJ is really the IDE powering things like WebStorm, PHP Storm, Android Studio if you're using Android Studio, and so on. So there's quite some IDEs based on that IDE. On the ReSharper side, this was actually ReSharper back in 2001. So ReSharper is a plugin to Visual Studio, but back then we did not yet know whether it would be a plugin to Visual Studio or an actual IDE. So we decided to build both. This is the ReSharper IDE from back then, built in WinForms. You can see that we didn't even bother updating the icon in the title bar there. But the idea of this IDE was to provide everything that IntelliJ could do for Java, do the same thing with ReSharper for .NET developers. So you see Solution Explorer, there's documents in there. Inside of those documents, that's quite cool. You can see the doc blocks rendered as a nice, well, the color is not that nice, but you can see it rendered not as XML comments, but as an actual block and an actual graphical thing. There's find usages in there. So all of the things that you know and love from ReSharper and maybe Rider were already in there at this time. Now, when we released ReSharper, we decided to not ship it as an IDE. So the ReSharper IDE standalone was halted as a project, but it has not gone to waste. Because at that time, we did not know that whether we would be a plugin or an actual IDE. The IDE for ReSharper was built with several concepts and architecture decisions back then. One of those decisions was to keep functionality separate from the actual IDE. So that means that while ReSharper has the same core for doing refactorings, for doing code analysis and all that, all of that is there. The IDE interoperability layer is something that sits on top. So all of the Visual Studio integration is something that connects to that core that is in ReSharper. So even though it was an IDE back then, the plugin and the IDE were basically the same core, just with a different front end on top of it. That also allows us, even today, to still target Visual Studio 2010. So if you would install a recent ReSharper version to Visual Studio 2010, that would all still work, and it works with all of the versions in between. And I don't know if anyone is using it, but there's also the ReSharper command line tools that you can run on a build server, for example. Well, that is also ReSharper. It's the same code base. It's just that the UI is, or the interface to the code base is a console application that gives you command line tools there. Now, at many of the conferences that we exhibit at, we have a booth. And at the booth, you very often get questions from people. And one of the questions that we got a number of times was that, when is JetBrains going to do their own IDE? That was a question that we got quite often. And that's one of the reasons why we decided to start building our own IDE, namely Rider. So why would we build a .NET IDE? First of all, people were asking us for it. Second of all, because ReSharper is getting more and more constrained by the Visual Studio environment. And it's not a blame game. It's really that VS is a 32-bit process. Visual Studio is in there, Roslyn is in there, ReSharper is in there, and 32-bit processes don't give you a lot of memory on .NET. You typically exhaust the memory space around 2.1 gigabytes, more or less. So that's an issue. Also, the fact that Visual Studio started doing these yearly and many times a year releases for Visual Studio means that there's lots of changes going on, and sometimes they impact ReSharper, and we can no longer be as quick with adopting those changes. So we decided, okay, maybe let's do our own IDE, so at least we also control that part of the equation. Back when we started discussing Rider was also the time that there was not a good .NET Core IDE that was good and also consistent cross-platform. We decided, okay, we can build an IDE that works on Mac, Linux, and on Windows, and is the exact same IDE, same UI, same way of working with it, and so on. So we decided, okay, all of those things combined, let's build a .NET IDE. Now, the fact that we wanted to make a cross-platform IDE means that we also would need a cross-platform UI toolkit. Since ReSharper is built on .NET, we would need something that could render the ReSharper UI elements cross-platform. Could be WinForms, but of course WinForms doesn't work on Linux and on Mac OS X. WPF, same story, would not really work. So if we would build ReSharper cross-platform, we would need to convert our UI to use something like GTK Sharp or Qt or something like that. Or if we would go the very hacky way, we could do some WinForms on Mono, because that sort of works, but also not ideal. So in essence, we would have to come up with a cross-platform solution for UI with ReSharper. Then we started thinking. We already have this IntelliJ IDE, which works on Linux, which works on Mac OS X, which works on Windows, and so on. We already have a number of other IDEs built on top of that one. So we have all of those IDEs, PHP Storm, PyCharm, RubyMine, WebStorm, and so on, built on top of that. And they also work cross-platform. Instead of rewriting the UI and so on for ReSharper, what if we could use IntelliJ as the UI for everything that we already have? And yeah, we decided to look into that as well. IntelliJ, the IDE, is actually the IntelliJ platform. So IntelliJ platform is the thing that powers all of our IDEs. It's open source, and it provides the base IDE, which has a project view, code completion, an editor, the UI toolkit, and so on. And for every IDE that we ship at JetBrains, we basically build a plugin on top of that IntelliJ platform and ship it as an IDE. If you're very adventurous and you want to build your own IDE at some point, which Google did with Android Studio, which Comma IDE did for Perl, I think. So there's a couple of open source IDEs built on top of IntelliJ out there as well. If you want to build your own one, you can go to the repo there on GitHub, download it, and build your own IDE on top. You can do that. It will be cross-platform because it's all JVM-based. It runs on Windows, Linux, and Mac, which is nice. Now, we decided to look at that IntelliJ platform to host ReSharper, but the thing is, if you start thinking about all of those things, IntelliJ is JVM-based and ReSharper is all .NET based. So how can you combine those two things in one project? Yes, IntelliJ is cross-platform, and yes, ReSharper could run cross-platform if we use Mono or .NET Core or something like that, but they are two different platforms. One is JVM, one is .NET. How do you solve that issue? Well, we had a couple of options. One of the options that we had was to maybe rewrite ReSharper in Java. ReSharper back then was already 16 years old, and we decided, well, maybe it's not a good idea to do the big rewrite, as you would say, the big rewrite of ReSharper in Java, because that would mean that we, first of all, would throw away 16 years of implementation and knowledge, but also we would be bringing two ReSharper implementations to the world. We would have one in .NET and one in Java. That's probably also not ideal. An automatic conversion could be some option as well, where we would convert some of the C# code into Java at some point, but we decided maybe that's not a good idea. The other option that we thought of was to maybe run ReSharper as a command line process. Out of process, make it possible to run ReSharper headless and then build our own UI on top. Well, the fact that we had that ReSharper IDE back in 2004 means that we already had a number of abstractions ready that would allow us to do this and run ReSharper as a command line process with our own UI on top. And that's what we decided to look into, IntelliJ plus ReSharper. Headless ReSharper as a language server for the .NET parts. Cross-platform could be .NET on Windows and .NET Core on macOS and Linux. No constraints for Visual Studio because we run in our own process. It can be ReSharper because we already had those abstractions, so it's really the same code base powering both ReSharper as well as Rider. And then on top of all that, we would plug IntelliJ as a thin UI controlling that headless ReSharper process. Awesome. Decision was made. We decided to build our own IDE. Now, if you start thinking about things, are both sides really what we thought they were? Is IntelliJ idea really a thin UI, or is it really an IDE? Turns out that there's actually three sorts of features in IntelliJ and ReSharper. There's features where IntelliJ can handle everything. There's features where ReSharper handles almost everything. And both IDEs are really two IDEs, and they can together make a more awesome IDE, which would be Rider in turn. So IntelliJ idea is not really a thin UI. It's really an IDE on top of another IDE. So we decided, okay, how can we work with that and maybe leverage features from both IntelliJ as well as ReSharper in Rider. So I'm going to give you a quick example of where this combination becomes visible. So if you open up any projects or any solution in Rider, you can see that, for example, if you do a web project, you will get Razor syntax as well as HTML. The cool thing is that in Rider, this Razor syntax is all C# and is handled by ReSharper, whereas all of this HTML is handled by the front end, by the WebStorm IDE that is actually sitting in the front end of Rider here. So everything I do here in terms of completion, and for example, if I would create a list that contains, let's say, 50 elements, and then in there we have a P and there's a link in there. If I tap there, this is handled by WebStorm. This is handled by the front end, and all of this is generated as HTML by the front end, while I can still mix in and sprinkle in some C# to handle all of the Razor syntax. So it's really two IDEs powering one experience. Same thing happens in code. We have a database connection that sits in IntelliJ. We have C# code that is powered by ReSharper in the backend. What you will see is if you start writing raw SQL queries or raw entity framework queries, you will see that inside of a string, you get code completion for a SQL database that you are connected to. So all of the C# that you see here is powered by ReSharper, whereas this string content, the fact that you can have code completion for elements and fields and records and so on from your database, this is all powered by IntelliJ, by the front ends, by the features coming from data grip into the front end of our IDE there. So the fact that you can have two sides of the IDE, both working together and doing the same thing, and I should log in there, I'm going to cancel that. The fact that you have those two IDEs operating together and working together to give you this experience is kind of nice because, yeah, you really get the best of both worlds. There's a couple of other places where there's one feature that is not in ReSharper, and that is local history. Local history is like a undo on steroids. You will be able to see all of the changes that were made to specific files, and you can basically revert to any point in time when you want it. And apparently I made a lot of changes to this file, so it might take a while to load. But at some point you will see that I can restore changes to the file that I have there. Actually, history is empty. Let's change that and make a quick change so you can see what I mean. So let's add a change, show that thing in action, and you will see that once it's loaded, it should give me back the entire history of what I've been doing there. Anyway, in the interest of time, I'm going to skip this thing, but trust me, this works. It's really undo on steroids and allows you to push back changes that you made throughout the day without having to commit them to source control. The cool thing is that it's all powered by the front end. This local history, ReSharper doesn't even intervene there, which is, again, a nice example of the fact that you're actually working with two IDEs at the same time. Cool. So how would we make those two IDEs talk together? How could we make IntelliJ talk to ReSharper? How can we make ReSharper talk to IntelliJ? Well, the data types that go over the wire, connecting the Java frontend with the .NET backend, are not that complex. If you think about context actions where you Alt-Enter, you see this light bulb and you want to provide a list of actions that you can do in the editor, basically you could represent those context actions as a tree of just names and icons. Same things with inspections. If you see those squiggly lines in the editor, what you can do is pass a set of names, icons, a severity, whether it's a warning or really severe error, maybe a tooltip, as well as the position in documents. That would be the data. You don't have to pass or remote objects into the front-end process. You can just provide that small set of data, which is the name, icon, and the tooltip. Same thing when writing code. If you're writing code, which you typically would be doing in the front end, you're writing code in the editor, well, you can give that code to ReSharper by simply not giving the entire document, but just giving all of the changes. You provide a delta with which line and which column you're actually making a change, and you give the text that has been inserted so ReSharper can also analyze that as well. So all in all, the communication between front-end and back-end are fairly simple messages. They can be made quite generic. So if we could make one inspection work, all of them could work. And if we could make a mechanism where we could simply pass along a set of names, icons, and severities, well, we can make all inspections work in Rider as well. So which protocol do we use in Rider? Well, we started looking at a number of protocols. So there's, for example, the language server protocol that VS Code is using. We have looked at that, and it's a great protocol in itself. It has IDE concepts like a window where you have an editor, you can have languages in the editor, you can have diagnostics where you pass along those inspections and so on. It's really great. All of that is in language server protocol, except that ReSharper has more things than would fit in the language server protocol. So if we would want to make sure that all of the ReSharper functionality was surfaced in the front end, we would have to extend the language server protocol if we were to use that. And that's possible, but if we would have to extend the language server protocol anyway, why not build our own protocol? So we decided to also look at a custom REST-like protocol where we have the front end making a request to the back end and then the back end responding something to the front end. We experimented with various serialization mechanisms. We tried JSON, we tried protobuf. We did a request response style protocol basically to make the two communicate. And it kind of worked, but it all felt a little bit sloggy. It felt not as fast and fun to work with as we would like to see it. We then started to look at why would we even use a request action response kind of cycle? Why would we use something that is language server protocol like? And why would we have a custom protocol that does a request and handles and does something and then gives back a response? If we use a request response type of protocol, every call that we make from front end to the back end would need context. Which solution did we open? Which project are we in? What's the file that we're currently looking at? What's the location of our cursor in code and so on? So all of that context would have to be part of the request so that the back end would know what to do with it. And then we realized, well, why do we even need that context? Why do we need that request action response flow? Why do we need this remote procedure call mechanism? Since both IDEs are built by JetBrains and they were built with the same philosophy, they all share a similar model and architecture. We have a project that has documents and each document has text ranges and so on. It's the same in IntelliJ and the same in ReSharper. So why would we even build a request response flow? What if we could have very simple messages that could just transfer the states from backend to frontend and from frontend to backend without having all of that overheads? So that's when we started thinking about model, view, view, model. IntelliJ could be our view, ReSharper could be the model, and the protocol itself, the communication layer between the two of them, could be the view model, sharing just lightweight data. And that's actually what we conceptually thought of building, which was what if we could have an object that is called projects. A project can have files, and we can add files to a collection. If we could model this in front end as well as on back end and make sure that the two know what the state is of our view model, then we're pretty much done, right? The protocol is not as simple as the one you would see on the slide here, but the idea still remains. We would have a project view model that has files as a collection, and we can add files into it, and somebody can react to that and maybe do something with it, such as running code analysis and so on. Right, there's one thing that remains. Even if we would use this model view model structure where you have multiple sides of the equation, there's one thing that remains, and that's conflict resolution. If you make changes to such a shared data model, those changes can come from both sides. You as a developer may be typing in a file while ReSharper is doing a refactoring. Well, if the refactoring completes after you already typed something, who is winning? What's the conflict resolution that you're going to adopt there? We looked at locking. So like when you're doing editing, for example, put a lock so you can't do a refactoring. We quickly decided that's not a solution because you get freezes, you get deadlocks, and all of the things that are common with locking. So we decided to come up with one very simple convention, which is when one of the sides updates the view model, every change comes with a version. We increment the version number. If you are doing something and you get a change from the other side that has a newer version or the same version, then we can apply it. If not, the change is discarded and both sides have to remodel everything and make sure that everything is up to date. So very simple convention, pretty much last one or newest one wins, so to speak. Right, let's talk about the actual protocol. The protocol itself would be something that communicates between the IntelliJ platform and ReSharper. And we decided that our diagram or our architecture would pretty much have to be something like this, where all of that communication would be magic. Ideally, none of our developers would have to know the details of the fact that there's this protocol in between. They should just be creating those view models and work with those view models throughout their development day. So this is what the protocol looks like conceptually. It's slightly more complex than that, but when you're using it as a developer working on Rider, it is really magic and things just work to communicate between both sides. The Rider protocol itself is a distributed communication framework that currently works in .NET, Kotlin, JavaScript, and C++. You may wonder why C++ if you're just doing Java and Kotlin and .NET. Well, C++ because last week we released Rider for Unreal Engine, which is all C++, and there's some C++ processes involved there as well. So we extended the protocol to also work there. It is open source. You can use it in your solutions as well if you need a similar type of protocol. And what you will see when you start using it is that it's really a stack of things. There's sockets, there's batching, there's a binary protocol of what goes over the wire. On top of that, there's the conflict resolution, the serialization, and things like that. All of those things you don't really have to care about as a developer. The protocol abstracts those things and makes sure that the model that you define using a DSL, a domain-specific language, is the thing that goes over the wire and exists on both sides of the product there. And then you build .NET code, you work with a .NET code generator. If you want to communicate with it using Kotlin, you get a Kotlin code generator that translates that model definition into actual codes that you can be using. Right, so the protocol, our developers only need to know about those few data types that are in there and work with the model. They can build that model, they can create classes in the model, and the model will reflect what the protocol will look like. The things like conflict resolution, the actual wire protocol, timeouts, the fact that you can have disconnects and so on, those are all handled by the library that we created. The code that you generate based on the view model is generated in the language that you are using, which means that since it's generated, there's no reflection involved, there's no JSON, ignore, and whatever attributes. It's really just C# code or Kotlin code that you work with that handles everything and that you can use to communicate between both sides of the IDE. It's also hierarchical and introduces lifetimes. That's a very vague statement, and I'll go into that in a minute. Architecturally, the protocol uses signals and events. A signal is basically I have an interface that I can fire an event to, and then there can be a sink listening to that event. And an event is a combination of something that happens and something that reacts to something. So that's pretty much the philosophy of everything in the protocol. So if in the protocol you would work with a list and add items to a list, those are all basically lowered down to just these 3 types of interfaces. You can also have properties that have values. So you can have a property on an object that has a value string, for example. That's really a combination of an event and so on that happens, and to a property you can subscribe to it, or you can see what the current value is. All details, I'll go into that a little bit later in an example. There's some primitives in the protocol as well. You can have signals, something is happening, I want to fire an event. There's properties where you can observe a value. Properties can also be lists, sets, and maps, and so on. And there's the typical data types that are bytes, shorts, integers, long, strings, and so on. Having that said, I'll quickly show you what the lifetimes are about, and then I'll show you some code of how this works in practice, because I know the slides are probably less clear than what would be in code. One important thing to know in an IDE is that everything has to be hierarchical, and you have to lifetime your resources. In a typical application, you can make use of disposables, for example, and put a using statement around something, and when you're done working with something, that object goes out of scope, or you call dispose and the object disappears from memory. In an IDE, typically your objects will be longer lived. If you open up a solution and I work with that the entire day, well, the object representing my solution will probably be around the entire day. So the last thing that I want to have in code is a big using statement around my solution, because I'm never going to exit there unless I close the IDE, right? So we decided to work with lifetimes, and lifetimes are an object that you can bind to. So if you have a disposable, instead of putting a using statement around it, what we do is we attach it to a lifetime as a disposable, and when that lifetime is disposed, we dispose all of the child objects there. Visual, you could think of it like this. If you have a solution that is open, the NUKE host in there attaches to the solution lifetime. If you have a project, that thing attaches to the solution lifetime. Document attaches to the project lifetime and the solution lifetime, etc., etc. So hierarchical, and you attach them all to a lifetime, which means if a document goes out of scope, the solution, the NUKE host, and the project remain in memory, but everything else can be discarded because that lifetime is closed at a certain time. The protocol extends this by also making the lifetime work cross boundaries, which means if in IntelliJ you close an editor tab, we will also close the lifetime in ReSharper, and that document in the backend will also be closed. So there's basically memory management going on the protocol between the two sides of the equation. Anyway, let's quickly dive into some code so you can see this in action. Right, in Rider, if you've ever worked with it, you will see in the NUKE tool window that there is a log tab. And in the log tab, we basically output everything that we can write there, probably too much sometimes even. But what we log there is which credential provider is being used, what is happening when you do a package restore, some debug information so you know what is happening on the background there. Well, the NUKE restore itself is handled on the ReSharper side of things, whereas, of course, the displaying of this log is happening on the IntelliJ side of things, where you see what is going on in there. So somewhere in our code base, we have to model a log that I can write to from ReSharper side and can consume on the IntelliJ side. And that is what this is. So what we have in the protocol is we have a model written in Kotlin where we say, look, this model has a sink, something that accepts RD NUKE log messages on a property called log. This is the protocol model definition where I define that I want to have an object in the protocol that will handle NUKE log messages on a property called log. We then generate code based on this, and we generate Kotlin codes that we can use in the IntelliJ side. And if we search for our log in there, you will see that at some point there is going to be a log property, that is generated based on that protocol definition that we just made. And this log is a list of RD NUKE log messages. Instead of having something that is specific to the protocol that we designed, you will get a traditional list that you would get in traditional Java and Kotlin as well on the IntelliJ side of things. On the ReSharper side of things, and I have ReSharper open in Rider. On the ReSharper side of things, we also generate code, but this time we generate it in C#. And here also we get a list that has RD NUKE log messages. The cool thing is, when we then plug this logger, when we plug this protocol into NuGet, what we can do is make use of our NuGet host, which is sitting on the protocol. And whenever NuGet logs something, which is this logger base interface, when NuGet logs something, we fire it into the protocol. And we say, look, in this log, we are adding a new NuGet log message with a certain string. That's all we have to do on the ReSharper side to pipe logs from NuGet into the protocol. On the UI side of things, again, in IntelliJ, we have a NuGet log panel. And this log panel is the UI that listens for events that are happening in the log there. We have that log property and we subscribe to it. It's like a reactive extension kind of thing where we subscribe to this log and we say, okay, whenever messages come in, we add those messages into the UI so they get rendered. So as you can see, this is a very, very simple way of doing things. I have a view model. I add messages on one side of the equation, and I consume them on the other side. And I can also do this vice versa, where, for example, IntelliJ could pipe something into that log property, and I could use that on the ReSharper side of things. So this is roughly how the protocol works. You define the model, generate code based out of that, and then you can start developing with it and just pass data over the wire, and the protocol takes care of everything that is underneath there. Right. So it's very extensible. It's a Kotlin-based DSL. Our developers don't really have to know a lot about the protocol. They can simply create that model, generate code based of it, and then work with the code that they generated. There's no real need to think about multiple processes. There's no real need to think about the fact that there may be network connectivity issues and so on. It all just works. Create the model and you develop against that model. If you're interested after this session to look into how this works, there's two plugins, the Unity support in Rider as well as the F# support are open source. Go and have a look because those two also extend the protocol and also communicate between backend and frontend in the plugin. Obviously, having those two sites, having that JVM world and that .NET world also means that writing plugins for Rider is slightly more complex than writing one for just VS, for example, or just Rider, or just IntelliJ, or just ReSharper. Anyway, have a look at those because it's really nice if you see it, you define the model, and things get generated out of that. Right. I promised that this talk was going to be about microservices in the IDE as well, because the title said microservices. I have 8 minutes left, so let's talk about microservices finally. Since we have two sites in the IDE, that is Rider, we have two processes. We have IntelliJ as a process, which runs on the Java virtual machine. We have ReSharper running on .NET or .NET Core on Linux and Mac OS X. And each of those two processes has their own 64-bit memory space and also their own separate garbage collector. Multi-core machines will benefit really greatly from this thing, because if you have a multi-core machine, IntelliJ can use some cores, whereas ReSharper can use some other cores, and those things will work together. We can start and stop those processes independently. Actually, if you just open Rider and you see the welcome screen, the ReSharper process typically has not yet started at that point. It's just the IntelliJ side of Rider, and once you open a solution, ReSharper will start and you attach to it. Starting and stopping independently also means that both can crash independently. So if something really goes wrong, we can still have the front end running, we can recover the back end, and something can happen to make things work again as well. If you are debugging in Rider, you're actually using 4 processes. You still have Rider, which is IntelliJ and ReSharper. You have your debugger worker process, which is a process that we run to communicate with your application. And of course, if you're debugging, you also have your application running. So there's communication happening between 4 processes at that time. So 4 microservices, so to speak, contributing to the same experience. We decided, okay, or we started thinking, if we have those multiple processes running on one machine to do debugging, how can we make this even cooler if we would spin up additional processes, share the protocol between all of those processes, and introduce more microservices in the IDE? So we did. What if certain features were running in their own process? If you are using the XAML preview in Rider, what you will see is that IntelliJ will run, Rider will, or ReSharper will run on the backend as well. And the rendering you see, the preview of the WPF of the XAML that you're writing, is actually something that is generated in a separate process. It's again a new process. And it's not that we have a request response style mechanism there either. No, we have ReSharper communicating with that previewer process, and it shares the same protocol that it does with the front-end IDE, which is kind of cool. The view model is or can be shared between multiple processes. So there's another feature in Rider where you can also load Roslyn analyzer. So if you have your own inspections, for example, that are written in Roslyn, you can run them in Rider. Well, we share the model of inspections between IntelliJ, between ReSharper, as well as our Roslyn analyzer process. If a Roslyn analyzer fires and says, look, I have an inspection to report, something is happening, I want this icon, this severity, this tooltip, and this is the text range in the documents, well, it simply can add that to a collection of inspections, and ReSharper will see this, and IntelliJ will see this as well. So we are sharing the view model between processes. You will actually see that as well. If you have Roslyn running in Rider, you will see that you get Roslyn quick fixes. But if you would look at the processes in your IDE, you will see that you actually have multiple processes running, which would be Rider itself, the ReSharper host, and then you get the Roslyn worker running there as well, contributing to Roslyn inspections. The fact that we have that protocol and the fact that it is a socket-based wire protocol means that we could also theoretically run the protocol on multiple machines. And that's also something that we are doing. If you're running Docker debugging or remote debugging, we actually pipe that remote debugger process into a separate machine, listening to your application, communicating with your application, while Rider is still communicating with that process remotely. So if this works with Docker and remote debugging, well, maybe we can even run it across the Atlantic Ocean and have a debugger process sitting in the US where we connect to it from a Rider instance running in Europe. So that could work in theory. If you look at the Unity game engine support that we have in Rider, you will see that we are also heavily extending the protocol there to make a really rich experience between the Unity editor as well as whatever we have in Rider as the IDE. So when you run Unity in Rider, you actually have Rider communicating with the Unity process. Unity communicates with your application. We can also debug and communicate with your application and combine all of that into one service. So this protocol, it's not that we have a point-to-point protocol where you have to do request response between every single party that is involved here. No, we again have only that one view model that everyone contributes to and that everyone can do something with. Actually, this is a nice demo of how this could work. So what you will see in this demo is that we have Rider running. And in Rider, we can do a find usages. And the usages that will be found will also be shown in the Unity editor. And this is really adding a couple of items to a collection and switching focus. So if you would run this, you would see in Rider, we do find usages. We select a usage and it pops open in the Unity IDE, which is kind of nice because all of those things can combine or can work together using that exact same protocol. Right, so I think I'm going to go over time for 2 or 3 minutes, but bear with me, almost there. The fact that we have this protocol, the fact that we have those microservices in the IDE also means that looking at the future, there's a couple of interesting use cases that we could be using in Rider. One of those use cases, and that's one that we're actually already using, is to also model the view on the protocol. Instead of having to use Swing in the IntelliJ side to draw the Java IDE, and in the ReSharper side, instead of having to use XAML, what if we could model the view as a protocol model and then generate a view based out of that? And that's what we do. So if you go to the C# interactive options in either in Rider, that is actually generated based on protocol messages, where we basically say, okay, look, we have a header, we have a toolpath selector, we have an empty line, we have another header, some Boolean options, and so on. And based on that, we generate the view as well. There's a couple of features in Rider and ReSharper where we are already using this approach to have the same UI in both ReSharper, the plugin to Visual Studio, as well as Rider, the standalone IDE. The fact that we can communicate across machine boundaries also means that we could do interesting things. And by the way, none of these things are working today, but they're just thinking about what we could do with the protocol. What if we, on a Mac OS or on Linux, could do the rendering of a WPF preview on a Windows machine while you are developing on your Mac OS or Linux machine? Using the protocol, using this microservices-based architecture, we could do this in theory. We could run the front end of the IDE on one machine and run the back end on another machine. So things like doing a live share kind of thing could also become possible thanks to this protocol. A really interesting thought experiment that some folks in JetBrains did was, what if every IDE would be both a client and a server to the protocol? What if ReSharper, sitting in Visual Studio, could make use of WebStorm's HTML, CSS, and JavaScript functionality? That's an interesting one. I don't think this one is going to happen, but in theory, using this protocol, using this view model, and having multiple contributors to it could mean that we can actually pull this off and make that happen. So to summarize this talk, I would say that Rider is an IDE built on top of two IDEs. We're actually leveraging the two IDEs in the IDE itself. Also two technology stacks, JVM and .NET. And we have to have a rich and easy programming model for our developers to work on both sides of that stack. The fact that we built that protocol also gave rise to the fact that we could run multiple processes to contribute to the same view model, and that we can also have more than one machine contributing to all of those things. And even we could do micro UIs where we generate a UI and have that piped over the protocol. With that, I would say thank you. And if there's any questions, feel free to ask. I didn't really check the questions in the meanwhile, so Eric, I will look at you there.
Yeah, so if you have any more questions, please ask them now. Just some facts. We have people watching from Delhi in India, Linköping in Sweden, Buenos Aires in Argentina, Gistel, Bierbeek, Borsbeek, Hasselt, Veldegem in Belgium, and Amsterdam, Den Haag, Eindhoven, Tiel, Haarlem in the Netherlands. So that gives people some time to ask questions. We have one question from Danny de Klerk. The picture you showed of the conference booth, was that the NDC Sydney booth?
That was NDC London, but good catch, that was an NDC booth, yes.
Wouter is asking, what's the relationship between Rider and the JetBrains toolbox?
So Toolbox is really a mechanism of delivering our software. So if you install Toolbox, you basically have a unified installer for all of the JetBrains tools. And Rider is just one of the tools that you can install from there.
Thank you. GC is asking, does Rider have a publish feature similar to Visual Studio?
Yes, it depends to where you want to publish. But if you want to publish to Azure, for example, or to IIS, check out the plugins, download the Azure plugin, and you will get publishing functionality there as well.
Shikola, I hope I pronounced that correctly, is asking, is there already some information about supporting Service Fabric in Rider? Would love to switch to Rider, but current project uses Service Fabric.
Let's say we have an open issue about that. Yeah. Nothing much going on there, so no. To my knowledge, I have no idea what the status of that one is. It's definitely something that is there, something on the back of our mind, but there's also lot of other things on the back of our minds.
Cool, thanks. Jan was asking if the IDE Vim plugin worked together with Razor, and I think Maarten answered that it's working together. We have some people stuck in Vim now, but and Danny de Klerk is asking, how many developers are there in the team actively developing R#, I, and Rider currently at JetBrains?
I could actually probably do a session about that, because the Rider team itself is probably around 20 people just working on Rider. The thing is that the fact that we run on IntelliJ, the fact that we leverage ReSharper also means that the Rider team theoretically also includes IntelliJ and also includes ReSharper as a team. So while not all of the things they are doing are contributing to Rider as a product, you could say that probably half of the company is developing Rider combined.
We have a question from Mappat, I think. We are missing a tool like DNS Spy on Mac. Is it a tool for attaching processes for debugging when there are no source code?
Yes, well, that's actually one of the really cool features that I find in Rider and pretty much use daily. That is that if you have third-party code that you're using, a NuGet library, .NET Framework code, or whatever, you can navigate into that code. It will automatically decompile, and you can put breakpoints in there, see what's going on in that external code while you are executing. So yes.
Cool. And Wouter is asking, how much effort would it take for an outside developer to introduce their own language server? Thinking of Visual Studio Code, which seems to promote that.
I would say contact me on Twitter or send me an email. It depends on what you want to do. It could be very complex. It could be very easy as well. If you're interested and already want to look at something, there is a PowerShell plugin for Rider where you can edit PowerShell, debug, run, I think, as well. That plugin is open source, and the folks from that plugin, they have actually been using language server protocol inside Rider, so the actual LSP, to make that work on top of the PowerShell LSP.
A question from Ken. Let me see, because it's a two-part question. Is the reference to the file passed between front and backend, so each plugin? Is the reference between the file passed between front and backend, so each plugin, ReSharper, WebStorm, etc., scans the file for parts it can improve, or does the front end send specific parts via the protocol, so each different plugin, again, ReSharper or WebStorm, scans the whole snippet?
Yeah, it depends. So if you have the editor, in the editor you open a document, and the document has text ranges where, for example, a class starts there, ends there. Typically, we send the documents as a concept over the wire. If one side needs the actual contents of that thing, it will build it themselves because they both have access to the actual document itself.
I think we have the last question from Erik. We have one more question, I think. The last question from Erik. How do you test? Also split in two tech stacks, or is it one?
We test in two tech stacks as well, yes. For ReSharper, we have a bunch of unit tests and integration tests and so on that run. We have the same for IntelliJ, and for Rider itself, we have a bunch of integration and UI tests where we do things like open up a solution automatically, do a couple of refactorings, then look at the memory even and do some performance analysis there as well, and then use that as a test result for Rider, the IDE itself.
Let's see, so I can get a link. I think Maarten responded to the question about the DN spy. Rider can't replace DN spy now because I need to attach to a process when I don't have any source code for it. So I can't get a list of assemblies in it, decompile one and put breakpoints.
If the process you're attaching to is an actual .NET process, it will all work. So you can also, from Rider, attach to running process, pause the debugger, and then look at what assemblies are in there and even put a breakpoint or search for a specific type and start stepping through things. Slightly more complex because you don't automatically know what the assemblies are, but you can still figure your way out. If you're interested, feel free to drop me a line, and I'll give you a couple of pointers on how to do that.
And let's do one last question. Maarten is asking, would love to see Scratchpad support for FSX CSX scripts to replicate linkpad on Linux. Are there any plans to extend Rider to Scratchpads?
Plans, we have so many plans. When are they going to happen? I have no idea. So this specific one, I cannot answer, sorry. But I know, Maarten, you have me on Twitter. And actually, I think you have half of the team on Twitter, so feel free to reach out.
So thank you very much for presenting. And let's continue on with the next session if Matthias is ready.
All right, cool. Thanks, everyone.
Thank you.
Yeah, so hi, I'm actually ready. Nice to see you all. Let me just quickly switch to my presentation. That's too far. Oh no, that's just the wrong tab. All right, so my name is Matthias. I also work at JetBrains, but what I'm going to talk about here is NUKE, which is a pet project of mine that I maintain just beside work. Also, hi to Maarten. I've seen you in the chat. Yesterday, I was actually fixing a bug that Maarten was reporting, and yeah, nice to see you also, but also everyone else. So I will talk about. Let me also just make it full screen. I will talk about NUKE, which is a tool for doing build automation, and I also make the bold claim that it is actually modern build automation for .NET and C#. And I will start by giving you a bit of background about what I have seen so far in relation to build automation tools. So the first that I started, and everyone is using to some extent, was MS Build. And if you're doing something more complex with build automation, so just because of the time is a bit short, just quickly, build automation are all the things to actually build our application that involves things like compiling solution, packaging to NUGET packages, pushing them. But as easy as those few examples seem, if you put more effort or over time, those things become much more complex. And with MS Build, that's also possible. We can write we can write our own targets. We can also escape to something called task assemblies to write actual C# code. But all in all, MS Build isn't really handy for doing build automation. So after that, and that was still at the previous company that I worked at, after MS Build, we switched to PowerShell. We also considered something like Pisaki, but for the sake of simplicity, I think at that time we stick with PowerShell. For probably one of the reasons was also that PowerShell is also known from the DevOps, or at that time, DevOps was not a term yet, but it is known also for operations teams. Yet with PowerShell, it turns out that there are a lot of unknown unknowns. So just a quick example or two quick examples. PowerShell has a very, I would say, surprising way of comparing with null, for instance. Null must always be on the left side of the comparison. Also, PowerShell, for instance, does crazy things like unwrapping collections if there's only one item. So you need to force it to keep it a collection. So all those kind of stuff. At my previous team, we actually skipped fake, although at that time it was becoming really popular. Probably the biggest reason for skipping it was that we would have to learn F#. So fake is based on F#. We would need to put that requirement onto our complete team. We could also pick just one person maybe, but then we end up in a situation where this one person is not reachable, is on vacation or something, and our build pipeline is just standing still. So we skipped fake. After a while, and I was already working at JetBrains, and at that time I had another pet project, which was called TestFX. And I was still trying to figure out a good way of doing build automation. And I used Cake at that time. So Cake is based on C#. But the issue I had with Cake is that it is actually is still a scripting approach. So what's missing with Cake is all the IDE tooling, including, well, Cake, they have actually extensions for many of the IDEs, not all actually, but Visual Studio and VS Code at least. So I use Rider. That was missing, but still with those extensions, it's still impossible to do some kind of refactorings, for instance, or to use find usages. So everything that we know how it works in normal C# code. And that was the time when I started doing my own thing with NUKE. Now, another disclaimer, and you might wonder, why should I use a build system if I have a build server like TeamCity, Azure Pipelines, and all that stuff? So yes, build server have the advantage. We can do continuous integration in a team. Yes, we also have historical monitoring, for instance, to see which tests are flaky and all that stuff. We have build parallelization, of course, to run tests in parallel, for instance. And we also have queue optimization. I'm not sure. I at least know that TeamCity is providing that, that when a certain build hasn't changed, then TeamCity will just use the previous result from it. Because if nothing has changed, then we don't need to build it again. And there are also some other optimizations in place. Now, on the other hand, some things that are not possible with build servers is with build systems, we can actually do local execution of our build. So that, with that in mind, we have a very fast feedback cycle. So if something is broken with our project, then just committing several times to the CI server isn't going to help us very much, because it might be blocked, or we block it for other folks. So the feedback cycle with build systems and local execution is really fast. Also, with build systems, we can properly debug our build. And we also have the advantage that we don't experience this kind of lock-in. So for instance, if we set up our build and it gets extended over time, then those build configurations, if they were on the build server side, we can't just say, okay, I want to switch to another vendor and use, let's say, Bitrise or GitHub Actions or anything, because that would mean we need to re-implement the whole build pipeline again in this other language. Let's say for GitHub Actions, it would be YAML. Everyone loves YAML, I know. All right. And with that being said, I will switch to a lot of live coding, actually. And I will start. I also have let me just switch here. I also have some kind of lineup here. So first, I will look with you at the setup and a simple hello world example. So in this case, we just have a solution. We have just a single project, but that all doesn't matter so much. What we do first, if we have our solution, is to install a global tool called NUKE. That command is also put on the documentation side. I have it installed already. And what happens if I call NUKE in this solution that's currently not built with NUKE, that we're going to get asked if we want to set up a build with NUKE. So I would just say yes. And now we're getting asked a couple of questions. For now, we'll just keep the defaults. So we're getting asked what our build project should be called. We'll go with _build, where it should be located in a subdirectory called build. We can also choose from a couple of versions. So you can see we also have the latest release. If there was a pre-release, you could also pick the pre-release and all those kinds of things. And also we are getting asked which solution should be our default. So many folks probably only have one solution. If you have more than one, then you can just pick none. But I will go with the default solution. And then there's also some more elaborate wizard that you can go through, which I haven't been working on for a long time. But at this time, it would just stop the wizard and finish the setup. Now, if I unfocus my terminal, then we can see Rider automatically reloads this solution, and we have a build project here. This build project, I get this question all the time, why is it marked as being not built? That is because if with that build, you're building the solution and the build is currently running, then we have we're locking the build execution. So it would build itself basically. So that's just to stop this building chain. And if we look into that solution, we can see we have a couple of bootstrapping scripts, which were cross-platform basically. Those bootstrapping scripts do mostly the same, or they actually do the same, which is just to ensure that, for instance, in this case, I was picking the .NET Core as a platform for the build, but we can also use .NET Framework, that also works. But for .NET Core, for instance, what this ensures is that we have the correct version of .NET Core installed, which also takes into account the global.json file, just so that that's there at any time if we execute our build. We can also see here we have a marker file. This marker file, I'm not sure if that will change at some point, but this marker file is just to, it makes it a little bit easier for everything that's built around NUKE. It basically sits next to the .git folder. So if we just watch the file system view, here's the git folder, here's also the .nuke file, and it basically marks the root directory of our complete repository. Why not using the .git folder? Because NUKE should work VCS agnostic as well. Okay, I will switch back. And now let's look at the build.cs file. And what we can see here is more or less the default implementation of a build. It's just some kind of scaffolding, basically. You can see our build class is inheriting from the NUKE build base class. And it defines actually a static in main method. So what does it mean? This is a simple console application. And everything we do here is just to delegate to NUKE as a framework to say, please execute the build. That's the same as here. And we can also define the default targets. We don't need to define default targets. We can also define multiple of them. That's also possible. But that's it for these for the entry point of NUKE. Now, what comes next, and I will just remove a couple of unnecessary things, is a couple of target definitions. So in build automation, we have this idea of build steps. In NUKE, they're called build targets. Same as with MS Build. I'm not sure about Cake, but we stick with the name target. And usually, if I would do this live, what I like to ask people is to take a guess in what those clean, restore, and compile targets actually are in terms of C# language constructs. And I will give you a second to think about it, and we'll also explain it just now. So those targets right here, those are actual properties, which also leads to the fact that we have defined compile here as a default target. We could go here and just say compile, please rename it. And we have it updated here as well. The same goes for restore. Compile depends on restore. We can rename it here. So we have basically the exact same tooling that we know from any other C# project in the world, just out of the box, without any extensions that we need to install. That also leads to the fact that if I put a breakpoint right here and I start my console application, then I can just debug it. And after a moment, and giving the debugger a bit of time to attach, then we can see the debugger has stopped here, and we can inspect the build object, for instance. If we would have defined a couple of more information, then we would see it here. But yeah, that's it for how NUKE works in essence. And let's stop. Now what I forgot, and usually I want to show this first. If we execute NUKE again now, after we have set up everything, then the build just executes. And we also see at the end, we have some kind of summary that will tell us how the status about certain targets, how much it took for them to execute, and everything else, basically. And now we could just go here and say something like, and we usually use the logger in NUKE, and say something like hello world. And what I like to do in my scripts, I shouldn't call them scripts, but build projects, is usually I do import static members just to make it look a bit nicer. And now if we execute that, of course, we can see our hello world. So that's it for the hello world example. I will now switch to the NUKE playground repository, and that's up on GitHub, so you can go there, clone it, and play around with it. And so now we will just go through a couple of examples that I've prepared. And I need to give a little bit of explanation here. This NUKE playground is a solution that has a source solution folder with one project and a couple of test projects. And also usually you would have only one, but we have in this case several build projects which will all do which will all show different kind of things. And one thing I forgot, actually, let me switch back to the hello world example. One more important thing, and that is especially for ReSharper and Rider users, is what you can do also. You see those little icons here next to the targets. We can actually go here, invoke Alt-Enter, the usual ReSharper and Rider shortcut, and from here we can decide to either execute the compile target, or to debug it, or to run debug without dependencies, which is very important for while you're doing the authoring of your build, while you write your build implementation. It's very nice to have that opportunity to just troubleshoot it, don't remove any dependencies and all kinds of stuff. Yeah, and just attach the debugger and be happy. I need to tell you also that, of course, I also care for the Visual Studio and VS Code users. In the documentation, you can also see how it looks for Visual Studio and VS Code. So in Visual Studio, we have some kind of tool window where you can pick targets from, and you have little buttons to attach the debugger and all that stuff. And in VS Code, it looks like that. Above every target, you have code lens items from which you can either run the target or debug it. But there's also a command palette support here, and we can run a target, debug a target. Basically the same thing. Okay, now I will go back to the playground project. And we will start with the target model. So we have seen that already with a small example. But here's a more complex one. We can see this tells us, please invoke NUKE -- plan, and I will just do it. Let me navigate to that particular build. So we need to go to target model. And from here, I will invoke NUKE -- plan. By the way, and I haven't mentioned that as well, with that NUKE global tool, we also gain the benefit of shell completion. So for instance, plan, or let's execute help. And I'll show you that with a couple of more examples. If we execute help here, then we can see all the targets that have been defined and all the parameters that we can pass. And so, for instance, for API key, we could simply do nuke --AP, and I would just tap now, and it completes to API key. The same goes for other parameters, like, for instance, verbosity. And verbosity has a defined set of parameters that I can pass. So I can type V for verbose and complete as well. So that works nicely. But for now, I will just invoke plan. And let's give it a second. And what NUKE does is to create a graph that shows us how everything is tied together. In this case, compile and restore are highlighted already because compile is the default target. Now, if I navigate around and if I hover over the target, that basically means what happens if I invoke that target. So if I invoke restore, only restore will be executed. Compile, restore will be invoked as well. If I go to, let's say, unit tests, then this chain of targets will be executed. We can also see that tests, for instance, has a dependency on integration tests and unit tests. So if I invoke that, then both of them will be executed. Now you might wonder, what is that dashed line right here? And those dashed lines indicate, those are, I like to call them ordering dependencies. So those that we have been looking at before are execution dependencies. So I need another target to be executed before me. Ordering dependencies will tell that only if the target is also invoked, it will be scheduled before the restore target. And that leads to the fact, for instance, that if I invoke, let's say publish has a hard dependency on clean, then we can see all of them will be executed, and clean will definitely be executed before restore. Now everything is highlighted. Why is announce highlighted? Because this has a solid yellow line and basically indicates that publish triggers announce. So it's some kind of a forward dependency. I like the idea to have it that way. We could also say announce has a dependency onto publish, but then we would need to invoke announce, which sounds, well, not exactly right. But if we invoke publish due to the trigger feature, we can also trigger announce. It will be just executed after the publish step. So if we go back, we can see how this is all defined. So for instance, let's go to the unit test. We can see this is dependent on compile. We can also see that it is dependent for tests. So we can also define those execution dependencies on the other target. The alternative for dependent for tests would be to go to tests and say dependent on. That's basically the same thing. So that would result in the same definition, basically. It's a matter of taste in many cases. But we can also say that when this is skipped, we should, for instance, skip all the dependencies. So when unit tests are skipped, we could say everything that unit test depends on should be skipped as well. Again, this is a matter of taste and how you like it. For update changelog, for instance, we could say that update changelog, it is a dependency for the publish target, and we could actually say that that we need this update changelog to only execute if we are currently on a release branch or a hotfix branch. So we also can define some kind of conditions for our targets. There's also the only when dynamic. The difference is only when static will be executed at the very beginning of our build execution, and only when dynamic will be executed right before a target execution. So one target could, for instance, prepare something, and another target could decide based on the results of that previous target if it should execute or not. What's very interesting is also the publish target, because right here we can define something like that the publish target requires that we pass the API key, or that it requires the Git to have a clean working copy. So if I actually never tried it, but if we invoke publish, for instance, let's try this. Then, okay, now I'm in the, how's it called? Interactive mode, so it will ask for the API key. But if I was to execute it on Azure Pipelines, let's say, and I can, how do you say, emulate it like that. On Azure Pipelines, I can't be just asked if I can provide the API key. Now we can see none of the targets have been run. None of them, even if just publish requires the API key. So this is some kind of fast fail behavior. We can declare we require this token or this API key. And if it's not there, and I just can't push my packages, then please tell me upfront, and not only when the complete build chain was executed, so up until there. And it would be a waste of time if those steps take, let's say, half an hour, and then we realize we haven't passed the API key. All right, that's it for the target model. Actually, I want to show you something else as well. It's a very nice thing in in Rider. And this is currently work in progress. We can also have some kind of live diagram, which will show us, just while we are writing our build implementation, how everything works together. So you can see in this case, this before restore is added and removed, and we can see how everything is re-rendered. So in this case, publish is only dependent on clean, but if we add it back, then we can see again that clean is at the very top. Okay, let's go back to the playground. Next thing I want to show you are parameters. And of course, one of the very important things for our build automation or build implementation is to pass in parameters, like API key, for instance. Parameters. And here we have a different build, which is provided already. And in NUKE, what you do is only to write a couple of fields and attribute them with the parameter attribute. That's all that you have to do. So it's basically a very declarative approach of doing parameters. And that results in the fact that here, if I invoke help again, then we can also see those custom parameters here: API key, array param, bool param, etc. Now we can try I have just a simple print target here, which basically just outputs what we have been passing. And we could print should be the default target. Yes, it is. And now we will just invoke it. And we can see most of them are null. Enum parameter is relative or absolute. Because we haven't passed anything, it will fall back to the default. It's an enumeration, and that's basically the 0 value. Now we can go here and, for instance, pass the string param, hello world again. We can pass the bool param. And for bool param, it's interesting because we can write true, we can also write false, but we can also use it as a symbol flag. So that will work as well. Now we have enum param, and here again we have completion for the possible values. So we can use relative, for instance, and array param. I just have to check what it's a string param. So we could do something like, let me see. And we can also define a separator. We don't have to. By default, it's space. But we can also write something like A plus B plus C. And now if we execute that, we see hello world, true, relative, and also here we have this collection of strings. So this part I have shown you already. So that's it for the parameters. Now path construction. And I'm sure everyone has run into this issue already where you work with a tool and you need to pass a path to a certain file and you pass it as relative, and maybe the tool is not supporting relative paths, could be. Or another case is you already changed the working directory and now this same invocation doesn't work anymore. So the idea in NUKE is to provide absolute paths at all the time. Now I will show you we have this property root directory, which is provided from the base type. This root directory is of type absolute path. And it's basically the same directory as the .nuke file, which I've shown earlier. Now from this root directory, we can do path concatenation with the division operator. So here I can go upwards again into the source folder, for instance. And now this is a very interesting thing with the division operator, because NUKE can internally decide if it should be a slash or backslash based on the operating system it's executing on. So you don't need to waste time thinking about that or guarding against that. And now we have, for instance, we have those definitions, those two targets. They will also automatically, they have an implicit conversion to string, so you can pass them as string as well. And here as the last step from this root directory upwards 2 steps, which is basically at the same point where this NUKE playground solution is located. We could, for instance, make a globbing mechanism and gather all the test folders. And now if I execute that, not yet in the right directory, it's called build path construction. Executing that. And we can see we have this path outputted. So they will also be normalized. And we have this collection of test directories. Now we could, I'm not sure what's the next thing I'm going to show you. It's the right one. Yeah, solution model. So we could, for instance, also gather all the test projects, the CS project files, right? So that exists as well, of course. So use glob files. So you can do that as well. We could glob them. A better approach is the solution model. Solution model. Let's switch to the next project. And with this solution model, what that means is that we automatically have all the we have an API to work with our solution. So basically this thing, the NUKE playground, we can work with that. And that's what the marker file is for. The marker file, you have seen it, it holds a reference to the solution. And I can load the solution in different ways. Like for instance, with this attribute again. By the way, this also ensures we can make those properties, those parameters read-only. But I can also define it with the constructor argument. I could, if I want to, I could also, solution model. I could also pass it, oh, that doesn't work. Let's see. I could also pass it as a parameter. That also works. I'm not sure why it doesn't show here. Actually, it should show here. But anyways, I could pass it as a parameter as well. And this object of solution, if I pass it just again as a simple string, it will hold the normal path. So if I invoke NUKE via attributes, then we will see it will just output the path for both of them. But we can also, and that's what I mentioned before, parse that solution. That's not needed because we have it already. But here it's just repeated. I can actually, I'm not sure why I did that, but that can be simplified. So this is the same object as here. Now if I invoke parsing, I'm sorry, my scrolling doesn't work so nice. If I invoke parsing, then we can see from the solution we get all the projects ending with tests, and we can also gather all the solution folders. And if I scroll up again, then we can see first we have all the test projects, and then we have all the solution folders, which are basically build, source, and tests. We can not only parse them and iterate over the information that we have, we can also modify them. So for instance, here, modifications, we just get our solution, which is the same, and add a project which is non-existent. And I will just execute that. And now we see non-existing target has been added with just a few lines of code. Very easy. It wasn't really great implementing that, I can tell you. Parsing solution files will never be my hobby, but having it is definitely a great thing. So let's remove that again. Okay, next in my lineup is tool invocation. And of course, tool invocation is something that's really important for build automation because we use such a lot of tools that are external, like NUKE, the .NET CLI, OpenCover, inspect code, XUnit, NUnit, all those kinds of things. And that was actually one of the first ideas why I started with NUKE, to have a proper way of doing those invocations. And I will show you how. So let's switch back to switch forward to the tool invocation project. And first I will show you a very easy thing. So the parameters don't really matter. But in its most simple form, it would be great to have some kind of string interpolation, let's say. And I have the .NET method that I can call, which is basically, if I type that out for you, what actually gets invoked is something like that. .NET restore, NUKE playground, and the next line, or should be here, would be .NET build, again, the solution, then configuration. Our default configuration is debug, so it would be debug, but I can also change it. I will do it in a second, and no restore. That's basically the same. Now I need to switch to that again, to invocation, and from here invoke the simple target. It was .NET. I should invoke NUKE and not .NET, then everything should work. So simple. And now for this configuration parameter, again, the same thing what I mentioned earlier. We can call --c for configuration. And then, because this is also, it's not exactly enumeration, but an enumeration-like class. And from here, we know that release exists, and we can execute it with release. Now we see the same as I've mentioned before. Those invocations, and I hope you can see it as it's also colored a bit differently, but they are our invocations. And the benefit of this absolute path is also that I could just copy that and invoke it from anywhere I like. So also the solution file was passed as absolute path. The configuration was passed and the no restore. All right, now let's assume, first another thing. The benefit of having those methods is also you don't need to care about where the executable is located. We can also do it for path executables, or executables that are reachable through the path environment variable. And then we just define a field again, mark it as tool and as a path executable. I could also grab basically an executable from a NUKE package like that. I define the package ID. I can define if I want to have different executables for 32 and 64 bits. And sometimes we also need to define a framework, because especially XUnit is providing executables for different frameworks as well. And those I could use in the very same way. So Git, for instance, I just use it as a method. And here you can see we can pass arguments, but also the working directory, environment variables, a custom logger, if we want to log the output or log the invocation, all that kind of stuff. So that works similar as the provided .NET method. Now, one issue with that, if we go back here, is let's say we want this no restore parameter not to pass all the time, but depending on some other circumstances. Or let's say we want to restore and we want to ignore the failed sources. So ignore failed sources is a parameter. And now comes the Fluent API. With the Fluent API, I can call .NET restore. I can set the project solution, project file. And now I can set to pass the ignore failed sources parameter based on the parameter that I have. So that is basically .NET restore, then our solution, and then ignore failed sources. But only if we define or if we pass that flag. So this is a Boolean, and I could also say something like, if I don't want that, I could also say enable ignore failed sources. This Fluent API gives the gives the opportunity to do that. Another example for this Fluent API, .NET build. We pass the solution, we pass the configuration. Since we restored already, we do the enable nor restore, and we can also pass the verbosity. Verbosity has a defined set of values that it can accept, and with code completion, we can immediately see that. One thing that's interesting about that Fluent API is that we can invoke the quick documentation here and show and see the same documentation as on the official websites. So here's a link to the official website, and we can also see this is a wrapper, a CLI wrapper with Fluent API. And here we can see all the arguments that are able to be manipulated with their respective properties. So for instance, it's not a good example, but this Fluent API supports many types like dictionaries, Boolean strings, all that kind of stuff. So .NET Pack, I will just skip that. Now, another thing, what's really interesting with that Fluent API, we could have a parameter which says to enable coverage based on our needs. So let's say, sometimes you just want to enable the coverage during testing. And we can do that with the extension method when. So the first part is a Boolean, and the second part will be only executed if enable coverage is enabled, if it's true. So we can do very easy composition. And again, here you can see Corporatura. No one has an idea what output formats coverlet supports, but with code completion, we actually do. Another one, let's say we have a couple of projects and we want to call .NET Publish for them, but those projects have different target frameworks. We might need to publish them for different runtimes and all that kind of stuff. First, what we can do is to collect all the published configurations. And this is basically just doing some kind of permutation. We end up with a collection of pairs between project and framework. And now the first part of this .NET Publish is the common one. Configuration will be the same for each and every one of them. The second part is a combine with call, and we pass our publish configurations and then just set the project multiple times. So this part here will be executed however or how many published configurations we might have here. I think it's only 2, but even if you have, let's say, 13 or something, this call will produce 13 invocations based on the published configurations that we have gathered here. A nice example is also, let's imagine you have a couple of packages that you want to push. And with packages, it's always interesting. Usually, they could be pushed in parallel. So I think a good number is to push 5 packages in parallel. But also sometimes only one package failed, let's say. And then if you re-invoke the push command for that, you still want to push all of them. So maybe the first only failed. You don't want to adapt your build configuration just to push all the packages. And so with NUKE, what you can do, and again, we have this pattern of calling the same parameters and then combine it with all the packages that we have gathered. And then we can just define a degree of parallelism, 5 in this case, and we can also define that it should complete on failure no matter what. So all the packages will be tried to be pushed all the time. I think for 2 invocation, I will do a bit of explanation here. So currently, this Fluent API is provided for a lot of CLIs out there. So if I go here, and this is actually a bit outdated, but you can see we have it for let's see, coverlet.cover, dubfinder. We have it for Docker. We have it for Kubernetes, Helm, etc. for many external tools. And of course, this Fluent API isn't written manually or something. What we do in NUKE is to gather some kind of meta information and generate it. And as of now, there are roughly like, I think it's 250,000 lines of code generated from this metadata. We can see it here, for instance, if I go to Docker generated to that file, and let me enable the line numbers. We scroll down here. Just Docker has roughly like 80,000 lines of code. Okay, let's go back. And this is something you can also do with your own tool. So let's say you have your own tool, which is not publicly available. Everything that you have to do is to provide some kind of JSON with metadata, and that contains stuff like this, for instance. So there's an output parameter that we can pass. It's formatted like that. It has a type of string. Here's the help text. And then you can generate that automatically inside your own build project. It gets generated automatically. Okay, let's go back to the lineup. NUKE also has dedicated strategies for build sharing. The first is external files, which works a bit like Git submodules, but a bit more lightweight. So external files, if I go to that CS project file, so here it's just a simple CS project file, then what I do is to define an item group, external files, and I can pass, in this case, I passed a GitHub reference. It's actually a folder, so it's not a file. I can say that it should be downloaded into the download subdirectory. And I can also make a couple of definitions, which then get replaced in those downloaded files. And I will show you right now. I still don't know how I get rid of that, this HTTPS thing here. But anyways, now if I invoke the build here for the external files, then in the output, we can see that all those files are getting downloaded. Has finished. If I go back here, in this case, I need to reload. We have a download folder, and we have all those files downloaded, which are in the same directory. And also we have replaced some values. So I passed .NET 5, for instance, or the NUKE version. In the original file, it looks something like that. But those things got replaced since we have this definition of NUKE version and target framework, .NET 5, which doesn't exist yet. All right. Another, and just by the way, this is the build sharing approach. So what you can do is to have one build implementation somewhere, and you don't need to care about it, to copy and paste it or something, but you just add the reference and it gets downloaded automatically. Another approach for build sharing is the global tool. And with the global tool, it's something like, let's say we have, this is our build implementation, and I have a target pack, install and uninstall. And this is kind of funny because we are using this global tool project to also install a global tool. But the interesting parts here is that we want to pack this build project as a tool. And we also want to define the command name. So if it's a bit of dogfooding here, because this build project itself will install a global tool at the same time. So if I invoke NUKE now, it will execute this build and it will trigger the install target. So first it will pack the global tool. That takes a moment. Then it will also uninstall the old one, and it will install itself in the current version. And now, since I defined this build command here, I actually have a command build, and this works the same as the build project. So I can call build -- help, and it will be the very same. Now you have seen it's much quicker because it is installed as a global tool. We don't have this bootstrapping scripts involved. Sorry, I have a bad throat today. Okay. Next topic, and that will be my last, I think. Yes, CI configuration. So we have seen, I will go back to my presentation here for a moment. We have seen how build servers are of great value, especially with the build periodization and queue optimization. And wouldn't it be great if we can make use of them even if we use a build system? So the conventional approach for build systems is that they have those bootstrapping scripts, which NUKE also has. But on the build server, the conventional approach is just to invoke one of those bootstrapping scripts, and that's it. And from then on, the complete build execution runs on a single agent. What you can do with NUKE is, again, we have this build definition here. We have a compile target pack, but we also have a test target. But as you remember, here we have 3 different test projects, and it would be great to execute them in parallel, right? So I'm not sure what I tell you first. Probably the single node invocation. Let's say GitHub Actions and AppWare, they can't run in parallel, at least as far as I know. But it would still be great to have them conveniently executed on GitHub Actions and AppWare. So how it works in NUKE is again, we have this build class, and now there's a partial file for that, for AppWare, for instance, and all we do is to put this AppWare attribute on it. We define on which images it should be executed, and we define which targets should be invoked, like tests, for instance. This attribute results in the fact that NUKE generates the AppWare YAML for you. This is generated, and we can see the images, and the bootstrapping script invocation. Now, another example with GitHub Actions here. For GitHub Actions, we need to define a name as well, but still we also define the images. We also define the trigger. We can also define more here, also for pull requests, let's say, in a code completion way. Very important. And again, the invoke targets. For the invoke targets, it's very interesting also that we can make use of the name of operator and then also compile. It's not here. Publish. Oh, that's interesting. Build, publish. I think it's not there. Let's check again. But there is the compile. Okay, I have no idea why that doesn't work. But even if, I think that's not my issue, but rather in Rider itself. Anyways, we can make use of the name of operator, and refactorings like renaming would still work. So then let's look at the continuous YAML file. Where is it? Oh, that's hard to find. I will just do it manually. It's here. Again, this is generated. We don't need to care about it, and we can easily run our build on different images by doing so. I will quickly show you how it looks, because here for NUKE I'm doing basically the same, and we can see it runs for multiple images, and we can also open here the invocation. GitHub Actions also supports collapsing certain targets, so we can easily see what happened in the pack target or what happened in the compile target and all those things. Now, those two were single agent CI systems, at least to my knowledge. Let's look at Azure Pipelines and TeamCity, because clearly in those cases, things can run in parallel. Let's get back to the playground again. And we will first look at Azure Pipelines. So in this case, again, the images invoke targets, and we have only defined, this is only for demo purpose. We could execute compile also on a different agent, but then we would need to do a bit more footwork, because we would need to pack the compilation stuff and provide it to the next target. So defining compile as non-entry target will make sure that test and compile are executed on the same agent. But that's only for this demo purpose. They could also run on different agents. But now for tests. Again, I said we have 3 different test projects, and it would be nice to execute them in parallel. For that to work, we go to our test target right here. And the first thing to make parallelization possible is to define a partition. It's called test partition. And since I have 3 different test projects, I would just say it's a partition of 3. The second thing is I will assign this test partition to the test project. Second step. Just so that NUKE knows that the test target is divided into 3 different pieces. The implementation is very easy. We have seen that approach before. We have a test projects property, which will give us the test projects. And then we just set it, etc. But here's something interesting. The test project property is implemented using the test partition. And it tries to get the current partition from all of the test projects. So if I wouldn't use partitions, the conventional approach would be something like that, and we would get all the test projects. But using the test partition, it will yield the first test project on the first partition, the second on the second, the third on the third. And just having those three definitions, the partition object, the assigning, the assignment, and using the test partition to get the relevant piece for the current partition will give us the opportunity to run things in parallel. So I have here the playground project set up in TeamCity, and we can see we have 3 different test run configurations, and they will all execute a different test project. For NUKE, I'm actually doing the same. Right? We can see, for instance, in this case, I have only 2 partitions. The first partition will execute the I will show you quickly. The first partition will execute NUKE common tests, and the second will execute NUKE global tool tests. And we can also see that the first one has 242. The second has only 1 test. But depending on how your build or how your test projects are structured, this is a great benefit. And I will give you the example of ASP.NET Core, ASP.NET Boilerplate, which is a big project. And for them, I think they had an execution time of 12 minutes before using NUKE. And with that approach, they are now down to 7 minutes. A couple of other interesting things is that we have looked at the parameter declaration. And for NUKE, I will just show you. Let's go to build publish. And by the way, navigation also works nicely. Publish, as seen earlier, requires the API key, requires Slack webhook, Gitter out token, etc. If I go here in NUKE on TeamCity, and here's the publish target, we also see it has deploy instead of run because it's a manually invoked target. If I execute that or try, then since those parameters are required, we also see this in the TeamCity interface, that this is actually required, and we need to provide those values. For Azure pipelines, it's roughly the same. So here is again NUKE build running on Azure pipelines. And here we can see it's running on Ubuntu latest, Windows latest, macOS latest. And if we open that, we can see compile, test, partition 1 and 2, etc. Okay, I think that's it for the CI configuration. I still have to show you. For NUKE, the generated Azure pipelines YAML, 130 lines of code that you don't need to invest into YAML. For TeamCity, it's a bit bigger. Sorry, 300 lines of code. Yeah. One more thing I want to show you, which is not related to CI configuration, is a really cool thing. If you have your build and you're working somewhere else, like NuGet package resolver, with Rider and ReSharper, you can invoke to execute a NUKE target. Then you have all the targets implemented at your fingertips, basically. And we can invoke the hotfix target, for instance. The same as I've shown earlier, we can debug it or run debug without dependencies. And also NUKE integrates with the run anything feature. So here we also have the same support, like ignore failed sources, and we could execute it from here very easy by hitting double control. So yeah, I think that's it. I still owe you the Azure pipelines. I know the TeamCity attribute here, which looks like that. Here we can also define a nightly trigger target. I think I should close, right? Someone enabled their microphone. Okay, yeah, so that's it. Just to show you a couple of repositories that are already using NUKE, some of the biggest ones that I know. And with that being said, thanks for watching. Would be happy to see you like in our Slack channel, for instance, or on Twitter following or something. But from now on, I'm open for your questions. So thanks for watching.
Thank you very much. Perfect presentation, super presentation. Some questions came in during the chat, during the presentation. Christoph is wondering if there is also integration with Octopus deploy for NUKE.
Yes, and with Octopus, it's really interesting because some friends from Octopus over there are actually currently in the process of contributing. So this generation, it's funny because, like I said, the tool, the Fluent API is generated. But this is, for some tools, brought even a step further, because for Docker, for instance, we even generate the metadata file, because even that is quite big. And the folks at Octopus Deploy are doing something similar to provide the full Fluent API interface, the full Fluent API to work with Octopus. So yes.
And Wouter is wondering, what if a coworker doesn't want to install NUKE on their machines? Besides trying to convert them to the other side, how can he ensure that the team can still move forward? Can he do...
This global tool isn't required to be installed, only for the setup. So, and I would assume at least the person who wants to introduce NUKE is able to install that global tool. But all the others, they can just use the the bash script or the PowerShell script to invoke. But they will miss the shell completion. Yeah, they don't need to install the global tool. NUKE itself is just a NuGet package that's added to the console application, and that's it.
Easy to install as well. Simon is asking, is NUKE intended to be used as sort of a meta tasks tool, considering the examples are involved things like .NET Build, which itself is a tool to build?
NUKE is basically does orchestration, so it's not intended to replace .NET or MS Build or any of these. But from my experience, I can tell you that, and I also mentioned it initially, that some build targets are really intense, and I have maybe a couple of examples. So, for instance, I'm generating a public API text file just to execute it for every release. And so this is much easier to write idiomatic C# code, basically, to have that opportunity to write something in C#. But for many of the known tools, we will just use command line tool invocations.
Let's see. And Marat is asking, why do you use UTF-8 symbols like the slider thing? I have a lot of problems with them, while Cake Build uses 4 issues for this case, and there are no such troubles.
I actually have no idea. So I didn't have any issue, and the UTF-8 was added in a PR to resolve some other issues. So maybe we need to find another encoding that should be used in that case. But it's really difficult because it's really really complicated to make it work on each and every CI system. And yes, I'm using some kind of as you have seen here, I'm using some kind of symbols just to make it look a bit nicer, like for the logo and all that stuff. but I wasn't aware at the time when I merged it. And since then, it's also, it involves some effort to fix that and also to make it work on different CI systems.
Simon. Oh, sorry. Ken is asking, in the post build target, can I easily load an assembly that was just built and parsed the DLL, for example, to generate the JSON file he described?
I'm not sure I understood the question.
Can I? Let's see.
I will quickly also. Will I find it? Probably not. Yeah. Can you just repeat? Let's try it this way, and if I can't figure it out, then please ping me privately. Let's do it this way.
Yes, Simon has a question. How does NUKE invalidate targets? Is that up to the leave tasks? Or does compile itself do stainless checks?
I still have no idea. please ping me privately on Twitter or anything.
Then an easier one. Mario asked what window manager you're using, and do you have your dot files published anywhere?
Window management. So I'm using OS X, and that's just the normal window management, but I have most of my applications in full screen. And for Rider, I just disabled most of the stuff, so I'm not sure, but I don't publish anything anywhere. This is just OS X here, which was with a mission control, and yeah, that's it.
I think that were all the questions. I think. Does anyone else have a question? No, I'm seeing any new questions coming. So I think we can get to the end of the meetup. Maybe we can get Maarten back on screen also. Yeah, everyone back. Hey. Yeah, so thank you all for helping out making this happen.
Yeah, thanks everyone for joining.
Thank you all, yeah.
Thank you for coming.
Thanks, everybody.
Thanks everyone.
Thank you. We hope to all see you next time or another time. Maybe in person or virtual.